This exclamation mark is not a warning. In math, this is called a factorial. A factorial is just another math operation like addition or subtraction, but this one tells you to multiply all the whole numbers less than or equal to the starting number, all the way down to 1, to get your answer. Here are a couple of examples. 3 factorial is 6, 6 factorial is 720, and 15 factorial is... If you plot the factorial function in a graph, it'll look something like this. Amazing graph. You can see that the graph grows pretty fast and it slopes upwards. However, if you peek at the left side of the graph, yeah, there are such things as negative factorials. But in general, you won't be using them, at least for this level of competition math. Even with just the boring positive whole number factorials, you can still do some pretty interesting things with them. And there are a lot of tricks you can use to make the math easier when you're given a problem to solve. What is 5 factorial divided by 3 factorial? Obviously, you could multiply all the numbers out and find the answer, but there's an easier way to do it. When you divide 2 factorials, most parts of each factorial will actually cancel out. Since 5 factorial is just 5 times 4 times 3 factorial, the 3 factorial in the numerator and denominator cancel out, and we're just left with 5 times 4, or 20. 4 factorial plus 5 factorial. Again, you could multiply it out, and with these smaller numbers, especially if you have the factorials memorized, it is easier to just add them together manually. But if it gets large, it might be easier to do it a different way. When you add or subtract 2 factorials, remember that you can use the distributive property to pull out the things they have in common. In this case, you can pull out the 4 factorial to get 4 factorial times 1 plus 5. And if you remember from earlier that 4 factorial is just 24, then this is just 24 times 6, or 144. Combining the things we talked about before, we can solve problems like this. Again, you could multiply everything out and solve it that way, but if the numbers get very large, it might be more difficult to do that. So you can solve this problem in a couple of different ways. You can distribute a 3 factorial in the denominator. In this case, the 3 factorial is canceled out in both of these fractions, so you end up with 5 times 4 plus 4 equals 24. A second way to do this would be to first distribute the 4 factorial. So you pull that out. Again, the 3 factorial cancels out in the numerator and denominator, and you get 4 times 6 equals 24 again. I'll tell you, more than once I've had questions ask me something that sounds a little bit crazy, like, what is the prime factorization of 10 factorial? Well, 10 factorial is a very large number, and it's not a good idea to multiply it all out. I discovered a good method for finding the prime factorization of a factorial. First, write out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Next, we're going to write all the prime numbers up to 10. And we're going to put tally marks under each of these numbers for how many times they occur in the prime factorization. And now we'll start to count. The prime factorization of 10 is 2 times 5, so add a tally mark under 2 and add a tally mark under 5. The prime factorization of 9 is 3 times 3. Add 2 tally marks under 3. And you just keep on doing this, tallying up the number of primes until you reach 1. And at the very end, you add up how many tally marks you have for each prime number. And this gives you the prime factorization of 10 factorial. This method just helps you stay organized when you're counting a lot of different things at once. There's still something that you might have a question about. What is 0 factorial? You might ask, 0 isn't positive or negative. My first intuition when I heard about this was that 0 factorial was 0, right? Because 0 multiplied by anything is just 0. So let's work it out and see. The definition of a factorial tells us that a number n factorial should equal to n times n minus 1 factorial. For example, 5 factorial must be equal to 5 times 4 factorial. That makes sense. Then we do that for 4. 4 factorial equals 4 times 3 factorial, right? 3 factorial equals 3 times 2 factorial. 2 factorial equals 2 times 1 factorial. And 1 factorial should equal 1 times 0 factorial, right? but we don't know what 0 factorial is. But we do know what 1 factorial is, and we know what 1 is. So for this equation to be true, 0 factorial must equal 1. Therefore, 0 factorial equals 1. Let's take a moment to do a couple of problems. You can put your answer in the comments and we'll comment back and tell you if you're right or wrong. And if you have any questions, just let us know and we'll do our best to answer them. Okay, so right now you're probably wondering why factorials are even a thing. Besides just making your life easier when you're writing down a bunch of numbers, where do we actually use them? So factorials are used extensively in probability. A classic example of a problem that might use factorials is, let's say you and 4 other friends go to the movies and you're trying to figure out what order do you like to sit in. So for the first seat, there are 5 of you who could sit there, so there are 5 choices of who can sit there. For the second seat though, somebody has already sat down in the first seat, so there are only 4 choices on who can sit in the second seat. The third seat has 3 choices, etc. So the answer to how many possible seating arrangements you have is 5 times 4 times 3 times 2 times 1, or 5 factorial. Another example is if you are choosing a locker code. This is a great locker drawing. A code consists of 6 digits between 1 and 45 inclusive, but you can't have any repeating digits. The total number of codes you could choose from is 45 times 44 times 43 times 42 times 41 times 40. You could write that out as 45 factorial divided by 39 factorial. A little bit more efficient to write. So hopefully you have a little bit of a better understanding of where you could use factorials, whether to help you write things faster or just to help you, do math a little better. So here are 2 more questions that you might want to consider. You can also put these in the comments, and we'll look over your answers. So again, thank you guys for watching. If you have any questions about what we discussed today, and if you have questions about math in general, feel free to put them in the comments and we will respond to them. Thank you.